On the last episode of Let's Dev, we talked about variables. We now know how to create them and know a thing or two about the data types they can contain. Today I want to put that theory into practice and continue working on the boot manager object we created in episode 2. Welcome back to Dodgy Dodo. So far we've been diving more into theory, but haven't yet created any useful functions for our game framework. That changes today. Let's write our first custom function. I've already removed the test variable since we don't need them anymore. To create a custom and reusable function, we need a place to write it and store it for later use. That's something we do in scripts. Let's go to the asset manager, right-click and create a script for the boot manager. I'll give it a prefix of SCR, an abbreviation for script, boot manager. As our list of boot manager related assets grows, you can see why I chose to use a prefix to differentiate between them. A new code editor window is automatically opened for the boot manager script. It has already created the default function and filled in some comments to notify us of some changes to the script system since GameMaker Studio 2.3. Since we're not working on an older version, I'm going to ignore this for now and delete the standard content. Before writing out the new function, I like to start off with providing some metadata. This makes life easier down the line. It's not absolutely necessary, but definitely good practice. We can use our special 3/ comments for that. First, I like to define the name of the function using the @function tag. Since we're going to use this to create an array that holds all of our system settings, I'll name it sys for system settings create. As we previously discussed, some functions need additional arguments to run. To make sure this will be displayed in the code editor when needed, we'll add a line with the @arg for argument tag. So far, our function doesn't have any arguments, so I'll put down none for now. And finally, let's describe what this function's going to do. After the @description tag, I'll say create an array for all system settings. That takes care of our metadata. To start a function, you simply write the word function followed by its desired name. As you can see, because we already gave it a function tag above, it shows up in the drop-down list and already adds the needed brackets for us. If we need any arguments, we can type those between the brackets. Now after this, we need some curly braces. Everything the function needs to do will be typed between the curly braces. Here we run into a hot debated topic in the programming community: curly braces etiquette. Some people like to leave the open curly brace on the same line as the function name and the other one down below the function code, like so. If you like to print out your code, it might save you some paper in the long run, but I greatly prefer to put the braces on their own lines. I think it creates clear boundaries between your blocks of code. Whatever you prefer, just make sure you're consistent in your code formatting. Messy formatted code can become quite an unreadable mess as it grows longer and longer. Now before we start creating a random array, let's make a short list of a few things that we want to have in the list. This is just to get things started. This list can always be altered or expanded upon later. Since every game is interactive, we should take into account that it can be controlled with different types of controllers. There's a good chance that each controller will need some settings tailored to it. Think for instance of button prompts. An Xbox controller has buttons with letters on it, namely A, B, X, and Y, while a PlayStation controller uses symbols: cross, circle, square, and triangle. It would be nice if we could display tailored button prompts on our game depending on the controller type used. Our first setting will be controller type, and its values Xbox and PlayStation. We also need settings for the different screen resolutions. We haven't yet decided which base resolution the game is going to have, so for now let's fill in some dummy values of popular screen resolutions. I'll create one for the horizontal size of the resolution, for instance 1280, 1920, and 2560. And the vertical corresponding sizes, 720, 1080, and 1440. Of course, we also want to be able to switch between windowed mode and full screen. Let's call this setting Window Modes, with the values full screen and windowed. And just for fun, let's toss in a setting for game difficulty, with the values casual, normal, and hard. If we look at the structure of this, we have 5 different settings for now, each with 2 or more values, which could quickly increase as features are added to the game later. This looks like we need a file cabinet with space for at least 5 drawers filled with data. Let's first create the base array with 5 main entries using the array_create function. This creates a basic array with 5 entries numbered 0 to 4. By default, these are filled with a value of 0. Now let's fill those entries with our data drawers. Before we continue, let's go back to our boot manager create event and make sure the syssettings create function is run. Remember, the create event is only run once. Since we don't need to create the settings array more than once, this will suffice. In the code editor, we can simply type the name of the function, closed by brackets and a semicolon. In this case, we only have to type part of the function and can make use of the dropdown. Let's double check if the array was created and display one of the entries from it using the showMessage function. Let's display the value of our PlayStation controller. The controller type entries are stored in file drawer 0 and PlayStation is entry 1. If we run a game pressing F5, the pop-up says PlayStation as expected. This means that the array was created successfully. If we change the first array entry to 3, we're accessing the values for window modes, which should result in the word windowed. Let's delete the showMessage function and go back to our boot manager script. Since we typed in a reference to the function, we don't need to keep the script window open separately. We can close it for now and simply use the middle mouse button to click on the name of the function. It'll automatically open the script for us in a new attached window and display the function. This is very useful when you have an ever-growing list of different functions in your script. As we're filling the array file cabinet with our drawers, we see that as the list grows, it may be hard to differentiate between the different entries purely by numbers and comments typed behind them. It would be nice if we could replace the numbers in the array with text labels. Luckily, there's a way to add human-readable labels to numbers. For this, we can use Enums. Enum stands for enumerator. They're basically a way to create lists of constant values tied to a number. Let me demonstrate. Since we're going to use the enum in our array, let's create it above it as code is read from top to bottom. You create an enumerator by typing the word enum followed by a name. Let's name this one setCat for setting categories, followed by curly braces just like in our function. If we start typing the names of our setting categories separated by commas, they're turning red. That means GameMaker Studio recognizes them as enumerator entries. What I've done here is write down 5 values. Just like in an array, these correspond with increasing numbers starting at 0. These function as labels for numbers. But instead of interpreting them as values, GML simply reads the terms as numbers. If we now type setCat.controller_type, GameMaker reads this as entry 0. Now we can simply replace all the numbers with the corresponding tags. We can simply read the category from the labels. Let's remove the comments and use some tabs to neatly organize our code. Because we needed a total of 5 entries for this array, we type number 5 in the array create function. As this list of settings grows, this might change. The enums correspond with the following numbers: 0, 1, 2, 3, and 4, because the entries start to count from 0. This means the number 5 in this case isn't used. If we add an entry at the end of this named array size, that will correspond with the number 5. We can now use this with our array create function. If we were to add a function to the settings array, say one called vsync, that would take the 6th spot in the array size and would now correspond with the number 5. This means array create will now automatically create an array with 6 entries for the settings. If we then add the setting for vsync to the list, we won't get into issues with the numbering and the available spaces for our data drawers in the array. Since array size is always at the end of the list, it will always create only the correct needed array entries. Let's add it to the list and leave it for now. Now to show you why I selected to use an array instead of separate variables, I'll show you an example of one of the many things you can do with an array. The system settings array is now basically a container that already contains a lot of data inside of it. If we want to do something with the data, we need to access it. Say I would want to create a menu where all of the difficulty settings would be listed on screen for the player. We could go over each of the game difficulty entries we know exist and list them out one by one. This is what we've been doing so far with the showMessage function, and that would also be our only option if we saved each entry as a separate variable. Luckily for us, there are other ways to list the entries contained in an array. For this, we can use loops. Loops are basically mini functions that perform and repeat a task until a certain condition is met. For this example, I use the for loop. The for loop needs 3 initial pieces of information to function properly. First, it needs a place to start. In the first bit, I'm giving a variable with the number 0, a counter basically. That will be our starting point. After the first semicolon is the condition for how long this loop will run. In this example, the loop will repeat for as long as the variable created is smaller than 3. The last part specifies what it should do in between. ++ adds a value of 1 to the variable. This functions the same as say I equals I plus 1. It's simply shorter notation. So it starts at 0, checks if the number is smaller than 3, and if it is, it runs the code between the brackets for the first time. After it completed, it'll add 1 to the counter variable. Next, it repeats. The counter is now 1, still smaller than 3. It runs the code again and adds 1 to the counter variable at the end of it. Once the counter hits 3, it stops. So we told the for loop for how long it should run. Now we can specify what it should do. We do that between the curly braces. To output strings so far I've been using the showMessage function. When you're trying to display a list of items, separate pop-ups aren't the most efficient way of going about it. So for this I'll use the showDebugMessage function. It basically does the same thing as showMessage, but instead of creating a pop-up, it displays it in the output window at the bottom of the workspace. As you may have noticed, each time you run your program, it gives you a whole lot of information about stuff that happens in the background. If you quickly want to output information to check if something works in the code, showDebugMessage works perfectly for this. Each time the for loop runs, it will display the string game difficulty option followed by the number of the counter, which corresponds to the numbered entry in the array 0, 1, 2, etc. Followed by a colon with a space and the entry. I've typed string I to convert the number in the counter variable to actual text. Since each entry in the game difficulty array is already a string, it doesn't need to be converted this way. Let's run this and see what happens. It neatly lists each entry accompanied by the string we specified. This is one way of building up a menu or for instance an inventory listing. This would simply be impossible with regular variables. That was just a quick example. We're well on our way of creating an administrative system for all our system settings and options. If you join me in the next episode of Let's Dev, we'll get started on the Display Manager. This will manage all the resolutions, window modes, and other graphically related fun stuff. That way we can replace some of the dummy values we created today with actual usable data. If you learned something useful today, don't forget to like the video, and if you want to learn more about GameMaker with me, you might want to subscribe to the channel. Thank you so much for watching and see you in the next video. And as always, have yourself an awesome day.